हेलो दोस्तों, हाउ आर यू? होप ऑल आर यू डूइंग वेल। दोस्तों यहाँ पे मैं स्टार्ट करने जा रहा हूँ हमारा लेक्चर 2 ऑफ बेसिक टू एडवांस लेवल रियल एनालिसिस कोर्स। सो हमारा जो फुल कोर्स है यहाँ पे IIT-JAM एंड CSIR-NET बोथ के लिए है। IIT-JAM और CSIR-NET के लिए पार्ट 1 एंड पार्ट 2 कवर होगा एंड पार्ट 3 एंड पार्ट 4 कवर होगा ओनली फॉर CSIR-NET। तो फुल सिलेबस जो है पार्ट 1 एंड पार्ट 2 कुछ इस तरह की है, आप लोग स्क्रीन के देख सकते हो। हम लोग अभी पार्ट 1 में है, फंक्शन, रियल नंबर सिस्टम, सीक्वेंस एंड सीरीज एंड कॉन्टिन्यूटी एंड डिफरेंशिएबिलिटी। इन द लास्ट लेक्चर विच वाज लेक्चर 1, आवर टॉपिक वाज फंक्शन एंड देयर प्रॉपर्टीज। वहाँ पे हम लोग डिस्कस किया था फंक्शन एंड टाइप्स ऑफ फंक्शन। हम लोग 1, 1, 2 बोथ ग्राफिकल एंड डिस्क्रिप्टिव डेफिनेशन दिया था। उसके बाद हम लोगों ने नंबर ऑफ 1, 1 और 2 फंक्शन काउंट किया था। उसके बाद सम प्रॉपर्टीज़ हम लोगों ने देखी थी एंड एट द एंड हम लोग कुछ इन्वर्स फंक्शन के बारे में डिस्कस किया था एंड हाउ टू फाइंड इन्वर्स फंक्शन डिस्कस किया था। नाउ आज लेक्चर 2 में जो कवर होगा हमारा टॉपिक है रियल नंबर सिस्टम। यहाँ पे आज कवर होगा लॉ ऑफ ट्रिकोनोमी, उसके बाद कॉन्सेप्ट ऑफ बाउंडेडनेस इन एनी सेट इन आर। उसके बाद हम लोग डिस्कस करेंगे अपर बाउंड एंड लोअर बाउंड विथ एग्जाम्पल्स। उसके बाद हम लोग डिस्कस करेंगे LUB एंड GLB विथ एग्जाम्पल, और वी कैन से सुप्रीमम और इन्फीमम प्रॉपर्टी। एंड लास्ट में हम डिस्कस करेंगे व्हाई R एंजॉयस LUB प्रॉपर्टी बट Q इज़ नॉट। मतलब रियल नंबर लाइन LUB प्रॉपर्टी होल्ड करता है लेकिन Q रैशनल नंबर पे LUB प्रॉपर्टी होल्ड नहीं करता। ये सारे कुछ हम इस वीडियो में डिस्कस करेंगे। तो दोस्तों आप लोग अगर इस वीडियो के बाद नोट डाउनलोड कर सकते हो हमारा वेबसाइट से, जो कि है www.mathnotespedia.in से। लिंक डिस्क्रिप्शन में मिल जाएगा आप लोगों को। आप लोग हमारे व्हाट्सएप ग्रुप भी ज्वाइन कर सकते हो रेगुलर अपडेट के लिए इस कोड को स्कैन करके। एंड फॉर एनी क्वेरी और डाउट यू कैन email me at mail@mathnotespedia.in। तो चलिए दोस्तों लेक्चर को स्टार्ट करते हैं। तो दोस्तों हमारा पहला आज का जो टॉपिक है वो है लॉ ऑफ ट्रिकोनोमी। क्या होता है? व्हाट इज लॉ ऑफ ट्रिकोनोमी? लॉ ऑफ ट्रिकोनोमी सेज दैट इफ यू हैव एनी टू रियल नंबर्स x and y, then exactly one of the following holds: x less than y, y less than x, or x equal to y. This is obvious because in the real line, if you have two number x and two number y, there is an ordered relation in the real line. Because of that, you can say either x less than y, or you can say x y less than x, or it also may happen x and y both at the same place. In that case x is equal to y. So in the law of trigonomy we can say that for any two real numbers either x less than y or y less than x, or x is equal to y. Note that for this law we can arrange the elements of our any order, that is the real number set has ordered relation. Now what is upper bound? Upper bound क्या होता है? Suppose A is a subset of R be non-empty, then the real number U is said to be an upper bound of the set A if x lesser or equal to y for all x belongs to A. इसका मतलब अगर एक रियल नंबर पे u एग्जिस्ट करता है एंड वी हैव एनी सेट, सपोज A is any set here, then u is said to be an upper bound of A if x lesser or equal to u for all x belongs to that set A. That means any element A के लिए u हमेशा ग्रेटर होगा A के हर एक एलिमेंट से, then we will call u as an upper bound. For example, if you consider the open interval 0, 1, if you consider open interval 0, 1, then observe that 2 is an upper bound of that interval. 2 is here, so every element between 0 and 1 always less than 2. That's why 2 is an upper bound of that set. Now if you consider 0 infinity has no upper bound. Why? Observe that 0 infinity मतलब 0 के राइट हैंड में चलता ही रहता है up to infinity. So here every element, if you take any element, you can find there an element which is greater than this element, right? If you find any u1, there exists an u2 such that u2 greater than u1. That's why u1 cannot be an upper bound. There exists always a greater element for any u1. That's why the set 0, infinity has no upper bound. So note that upper bound is not unique, right? It is obvious because we have already checked that 0, 1 का जो upper bound होता है वो 2 होता है. अगर आप 3 भी लोगे वो भी upper bound होगा, 4 भी होगा वो भी upper bound होगा. So there are infinitely many upper bound for any set if it exists. Okay, अगर upper bound exist करता है तो वो infinitely many होता है, वो unique नहीं होता. That's why upper bound is not unique. Now let us discuss what is lower bound. In the similar fashion, we can also define lower bound. Suppose A is a subset of R, then a real number L is said to be a lower bound of A if x greater or equal to L for all x belongs to A. What that mean? If you have any set A and L is any element, then L is said to be a lower bound if for every element in that set A, it has to be greater than L. Okay, x greater or equal to L. Then L is called a lower bound. Okay. For example, so -2 is an lower bound of 0, 1. It is obvious. Suppose 0, 1 is here, so -2 is here. So -2 से 0, 1 का हर एक एलिमेंट बड़ा होगा, इसीलिए -2 is an lower bound होगा. Now in the similar fashion like 0 infinity, if you consider -infinity, 0, observe that this set has no lower bound. ठीक है, -infinity इधर जाता है and 0 is here. So if you consider this interval, observe that there has no least element. If you consider any lower bound here as L1, then there exists a smaller element L2. That's why this set has no lower bound. There always exists an element which is lesser than the lower element. That's why this set -infinity, 0 has no lower bound. So also here the notable thing is that the lower bound is also not unique like the upper bound. Now what is boundedness of a set? Suppose a subset of R, then bounded above हम कब कहेंगे? There is two concept actually boundedness के बारे में. एक होता है bounded above and एक होता है bounded below. Now what is bounded above? A is said to be bounded above if there exists an upper bound of a set. So अगर कोई भी set A का अगर upper bound exist करता है, in that case we will call this set is bounded above. So 0, 1 is bounded above because we have already checked that 0, 1 has an upper bound 2. That's why we can say 0, 1 that set is bounded above. So now what is bounded below? Similarly, if a set is said to be bounded below if it has a lower bound by same argument. So 0 1 again we have already checked that -2 is a lower bound, so lower bound exists for 0 1 open interval, that's why 0 1 is an bounded below set. So when we say a set is bounded, if it is both bounded above and bounded below, then we will call A is an bounded set. Now let us see an example. 0, 1. We already have said that 0, 1 has an upper bound, so it is a bounded above set. Now we have already said that it is bounded below and hence it is bounded. Now let us check another example. Consider 1, infinity subset of R. Let us check whether it is bounded above. It is bounded above. Observe that 1 starts from here and goes to infinity. So it has no upper bound, because if you call any number is upper bound, then there always exists an element v which is greater than u. So u cannot be an upper bound. That's why this set has no upper bound. That's why this set is bounded above, we can't say. So bounded above, no. Now bounded below होगा क्या? Observe that 0, 1 is bounded below. Why? Because it has an lower bound. 1, infinity जब आप लेते हो, so any element here, suppose -1, -2, anyone can be the lower bound. That's why it has an lower bound and hence it is bounded below. So bounded below, yes. Now it is bounded, as it is not bounded above, that's why this set is not bounded. Now finally come to the very important property, which is least upper bound or supremum. So when we call a set has least upper bound or supremum, suppose A is a subset of R, be non-empty set, then a real number u is said to be least upper bound or supremum if these two conditions holds. The first condition is u is an upper bound of A, and for any other upper bound v we must have u lesser equal to v. That means in the real line, suppose you have any set A, आपके पास एक सेट A है and u is an upper bound is given. U is an upper bound. Now u is said to be lower bound if there exists another set, another element v such that u lesser equal to v. मतलब v हमेशा u के बाद रहेगा, कभी भी यहाँ पे नहीं हो सकता. In that case we will call u is a least upper bound, मतलब the lowest of all upper bounds. हम लोगों ने पहले भी देखा था कि अपर बाउंड यूनिक नहीं होता, देयर एग्जिस्ट इन्फाइनाइटली मेनी अपर बाउंड, बट अगर हम उस सारे अपर बाउंड में से हम लीस्ट को ले लेते हैं, लोएस्ट को ले लेते हैं, दैट लोएस्ट वैल्यू इज कॉल्ड द लीस्ट अपर बाउंड or the supremum of the set capital A. That's why we can say that this least upper bound is unique. Upper bound unique नहीं होता, but least upper bound or supremum is the unique value because it is the lowest value of all the upper bound exist of a set. Let us see an example. Observe that for 0, 1, 1 is the least upper bound. Why it is least upper bound? Because if you consider 0, 1, then every element greater than 1 is an upper bound. But observe that that one value is the lowest. Observe that if you take any smaller value than 1, then it cannot be an upper bound. Okay, so that's why 1 is the smallest of all the upper bound exist. That's why 1 is the least upper bound or supremum of that set. So remember that upper bound is unique. Now greatest lower bound. What is greatest lower bound? The same argument for lower bound we can define greatest lower bound. Suppose A is an subset of R is non-empty, then L belongs to R is said to be GLB or infimum if it satisfies these two conditions. First, L has to be a lower bound, and second, for any other lower bound we must have less or equal to L. So suppose this set we have A. Okay, now first is L is a lower bound, that means L something here. So if there exists any other lower bound, ठीक है, सो वो यहाँ पे नहीं रह पाएगा, वो हमेशा इधर रहेगा, के हमेशा इधर रहेगा, सो दैट के लेसर इक्वल टू एल होता है. दैट मीन्स फॉर other lower bounds we have to take the greatest lower bound, which is the L. L is the greatest of all the lower bound that exist for capital A. We have already seen that lower bound is also not unique. There exist infinitely many lower bound, but if you take the greatest of all the lower bound, in that case this is unique and this is called greatest lower bound or infimum. Let us see an example. The same example 0, 1. Observe that 0 is an GLB or infimum. Why GLB or infimum? Because 0, 1 के जो लेफ्ट में 0 के लेफ्ट में जो कुछ एलिमेंट है सारे के सारे लोअर बाउंड है, बट 0 इज द ओनली एलिमेंट which is lower bound as well as it is the greatest of all the lower bound. Okay, that's why 0 is the greatest lower bound or infimum of the set 0, 1. Okay, so what we have seen, greatest lower bound is also unique. Okay, did you get it? Okay, now what is LUB property of R? This is very important property actually. Suppose A is a subset of R which is bounded above. Okay, so bounded above imply करेगा कि LUB exist करेगा. Similarly, we can say if A is bounded below, then A has a GLB or infimum, this property. Okay, by similar reason. Now the important thing to note that Q does not enjoy LUB property. Q में LUB property hold नहीं करता. This is very very important. For इसको show करने के लिए let us consider that set A is equal to x belongs to Q such that x square less than 2. Observe that हम लोग x Q में ऐसा एलिमेंट ले रहे हैं जिसका स्क्वायर लेस देन 2 होता है. सो यहाँ पे एक्स स्क्वायर लेस देन 2 मतलब x लेस देन √2, मतलब उन सारे रैशनल नंबर को हम ले रहे हैं जिसका वैल्यू एक्चुअली √2 से कम है. ठीक है, So observe that if every element less than root 2, so root 2 becomes an upper bound of the set capital A, and also it is the least upper bound, because if you take any value greater than this, something greater than this, then this will be not be an upper bound. So root 2 is the only lowest upper bound. That's why root 2 is equal to LUB of a least upper bound or supremum. But observe that root 2 does not belongs to Q. रूट 2 Q में नहीं रहता क्योंकि रूट 2 इज एन irrational नंबर. That's why capital A does not have any upper bound in Q. But note that capital A is bounded. Why it is bounded? Because every element in that set is less than root 2. But root 2 does not belongs to Q. It belongs to irrational number, Q complement. That's why a bounded set in Q does not have लिस्ट अपर बाउंड ऑल्दो इट इज़ बाउंडेड. हम लोग लिस्ट अपर बाउंड प्रॉपर्टी क्या पढ़े थे कुछ देर पहले, कि अगर कोई भी सेट बाउंडेड होता है सो इन दैट केस इट मस्ट हैव LUB इन R. ठीक है, R का कोई भी सबसेट अगर बाउंडेड अबव होता है तो U में R में एक बाउंडेड सेट का हमेशा लिस्ट अपर बाउंड और LUB एग्जिस्ट करेगा. U यहाँ पे LUB होगा, लेकिन हम लोगों ने देखा Q में ऐसा नहीं होता. Q में एक बाउंडेड सेट तो हमने लिया, लेकिन उस सेट का जो सुप्रीमम हो रहा है वो एक्चुअली Q कॉम्प्लीमेंट पे जा रहा है, वो Q में नहीं रह रहा. इसीलिए दिस डज नॉट सेटिस्फाई द LUB प्रॉपर्टी. दैट्स वाई Q डज नॉट हैव LUB प्रॉपर्टी. ओके, सो दैट्स इट. This is the proof, you can see. Now one final example. Consider that set capital A is equal to 1 by n. Now this is a subset of R because the element of that set look like this: 1 half, 1 by third, 1 by 4, like this. Now observe that this set is bounded above by 1 because every element of the set 1 is the largest element of that set. उसके बाद सारी के सारी एलिमेंट कम होता जा रहा है. 1 by 2 is less, 1 by 3 is less, 1 by 4 is less. So 1 is the largest element, and so this is the bounded above. Okay, so also note that 0 is the greatest lower bound. Why it is so? Because every element of that set is greater than 0. ठीक है, 1 by 2, 1 by 3, 1 by 4, every element is greater than 0. So and it tends to, जब 1 by n लार्ज हो जाएगा वो टेंस टू 0 होता है. सो 0 के बहुत निकट होता है, लेकिन ऑलवेज ग्रेटर देन 0 होता है. दैट्स वाई दिस सेट इज बाउंडेड बिलो बाई 0. फ्रॉम दैट वी कैन से दैट दिस सेट LUB is 1 and GLB is 0. So this is an example where this is the set A is bounded. First it is bounded. How it is bounded? It is bounded above by 1 and bounded below by 0. That's why we can say that A is bounded. So by LUB property, A has an LUB, A has LUB, and by GLB property, A has also GLB, and we can found this by LUB is equal to 1 and GLB is equal to 0. Okay. So that's it for now today. We have to stop now. In the next lecture, we will discuss application of LUB axiom, okay, where we will discuss the Archimedean property. So see you in the next lecture. Till then, goodbye.